All right, this is a continuation of the notes that we were working on in class. The section was 1.3 factoring and then the beginning of 1.4 with rational expressions and operations and simplifying rational expressions. So the first thing I'm going to do is I'm going to finish up some of the factoring problems or examples that were left over in the notes. We went through one of every type of factoring technique, but of course there's never enough time always to do all the examples. So I'd like to do them in the video format so that you can watch them as many times as you need and stop and pause or whatever you need to feel comfortable with the material. So we're starting with, this was example number 1, I believe, part F from the 1.3 notes. And we're looking at factoring something that has two terms. So remember, the things that we learned is that you have to look first to see if there's a GCF. I do not see anything in common that I can pull out. If that happens in a binomial, your only other options are perfect squares or perfect cubes. So since I see this is y cubed and 27 is a perfect cube, I usually try to think, this is maybe a perfect cube situation. So we have to check. Could both of these be written as something cubed? That's always kind of how you're asking this. So if we want this to be cubed, we'd need it to be x squared. The reason I know that is because 2 times 3 would make the 6. 27 is 3 cubed, and y cubed would just be y. So this does fit the pattern of something cubed plus something cubed. Now we learned a technique that's called the SOAP technique, essentially. When you have two perfect cubes, there's a formula for how it's supposed to factor. It's always a binomial and a trinomial. If you've broken these pieces down, the binomial comes straight from here. It's this symbol right here and both of these roots. So this would be x squared plus 3y. The middle parts, or the trinomial here, this big thing that needs 3 terms, you take each of these guys and you do what I call is multiplying all pairs together. What I mean by that is the first thing we do is say, what happens if we multiply x squared times itself? And then our second question is, what happens if we multiply x squared times 3y? And then our final question is, what happens if we do 3y times itself? Now, this isn't just something random that we decide to do. The reason this works out the way it is and why it factors this way is when we put in our signs, if you were to FOIL or distribute all of this out, all of the middle terms cancel and you just get this and this left over. So x squared times x squared is x to the 4th. I don't worry about my signs yet. This would be 3x squared y, and 3y times 3y is 9y squared. Now we learned, like I said, an acronym SOAP that stands for our signs, and this last one has 2 variables. This means same sign as the original problem, so that's why it's a plus, opposite to the original problem, so that's a minus, and always positive. There should only be one negative in a perfect cube factoring. And it either has to happen in the binomial or here. Those are your only 2 choices. So if this had been a minus right here, this would have factored exactly the same, except this would have been minus and this would have been plus. So that's the only difference. Okay, looking at G, we have 4 terms. Anytime you have 4 terms, you should try to factor by grouping. Always check for a GCF first, but I don't see anything that they all have in common. So I can pull an A and a Y out of the first pair. That would leave me with a 2 and a y still for the first term and a minus x. For this pair, I think I can pull out a positive 3 since this leads with a positive, and they both have an x in common. 6 divided by 3 is 2, pulled the x out, still have a y. Negative 3 divided by 3 would be negative 1, and I pulled out one of the x's. You know that this successfully factors if the parentheses match. So that is one of my answers, is just that common parentheses. The other answer is the parts that they had out in front. So ay plus 3x. Okay, let's look at H. Now H is the same thing. You have 4 terms, except if you're paying attention, you would notice you can pull a 5 out at the very beginning. So I'm going to show you what this would look like if I pay attention and then I'm going to rework it and show you that if I did not pay attention, I have something happen at the end that causes my answer to be slightly wrong, and I would have to fix it. So if I pull a 5 out, this would be x cubed plus 2x squared minus 4x minus 8. I just like to kind of bring that 5 down so I don't lose it, and then I worry about this. So I can pull an x squared out of the first pair, and that would leave me with x plus 2. I can pull a minus 4, because this leads with a negative, out of the second pair. That would make me this an x, and do be careful here. Negative 8 divided by negative 4 is positive 2. That would pull to the front as x plus 2 since they match, and then I have an x squared minus 4. And then I'm supposed to remember to check anytime you have something squared left over, you do need to check to see if these are perfect squares. Because if they're perfect squares, they factor as well, and if it has a minus sign between them, we learned that, and this would be x plus 2, x minus 2. So I'm writing that in red so that you can see that that's actually from that x squared minus 4. Now another way to write this, if you wanted to simplify a little bit, is you could write x plus 2 squared. That says that there were 2 of those in the final answer. I'm okay with it split up like this, but if you wanted to be a little bit more shortcutty and simple, you could write it as squared. Now what I pointed out to you is that I remembered to pull my GCF out at the beginning. If you did not, you will see, and I'm going to do this in blue to show that this is not how I would recommend doing it, but you can fix it at the end if you're not careful. So say I'd forgotten to check for the 5 at the beginning. I would have pulled a 5x squared out of the first pair, and that would have left me with x plus 2. I could have pulled a negative 20 out of the second pair, and that also leaves me with x plus 2. I then have a x plus 2 that they have in common, and then 5x squared minus 20. And you would have looked at that and said, oh, no perfect squares, okay. But they both have a 5 as a common factor, which means we did not pull out our GCF. So we would need to pull that to the very front, still leave your x plus 2 the way it is, and then we would need to divide that 5 out of both of these. So this would be x squared minus 4. And then again, I see that, oh, that factors again because x squared minus 4 is x plus 2 and x minus 2. So just be careful if you don't check for the GCF at the beginning, it may pop up in one of your answers at the end that you have to pull that out. And then let's look at I. I has no GCF that we can pull out of everything. We can pull an x cubed out of the first pair. That leaves me with x minus 3. I can pull a positive 8 out of the second pair. That also leaves me with x minus 3. So I have an x minus 3 and an x cubed plus 8. This guy right here is 2 perfect cubes, so this will factor. So I'm going to bring my x minus 3 over, because that's still part of my answer, and then I know I'm supposed to have a binomial and a trinomial for these perfect cubes. This would just be an x and a 2 if we worried about what were they before they were cubed. So remember, once you know what your 2 roots are, you write them once with the symbol in the middle. That's the binomial part, so x plus 2. In the trinomial, you do each of those in pairs. So x times itself, x times 2, and 2 times 2. We don't worry about signs right now. So this is x squared, this is 2x, and this is 4. And now we say our SOAP analogy. Same as the original, opposite sign to the original problem, which right here was a plus, always positive. So this is a final answer format for that. Something to note about perfect cubes, the trinomial will never factor any further over the integers. You could try to use quadratic formula to solve this later on, but it won't factor. So right now this is just in final format since all we're doing is factoring. And then let's look at this last one under the factoring part. So this is the last one for the 1.3. I can pull out a GCF of x. So I have 4x squared plus 4x plus 1, because there is still something here once you pull that x out. This is not an easy factoring because this does not have a 1 in front. So I'm going to do some scratch work over here. I have 4x squared plus 4x plus 1, And since it's a trinomial and there's no GCF and this is not a 1, I'm going to try the factor by grouping method. So that means you multiply the first number, which is in front of the x squared, times the constant. And that just gives me 4. So that wasn't very interesting, but that's what you have to do no matter what, if this is not a 1, if you're going to use factor by grouping. So this is a 1 and a 4 and a 2 and a 2. Out of those pairs, we need it to be multiplying to give us a positive 4, so it has to be either both negative or both positive, and they have to add to positive 4. So it looks like it's going to be a positive 2 and a positive 2. So remember, my next step is to take that middle term and split it into 2x and 2x. This is where we get 4 terms. And the reason we want 4 terms is so we can factor by grouping. So this is my scratch work for this. So I can pull a 2x out of the first pair. That would leave me with a 2x plus a 1 because you do have to divide 2x by itself. That does leave a 1 behind. The second pair has nothing in common. You still have to pull something out. So anytime it's nothing in common, we either pull out a positive or negative 1 depending on what this symbol right here is. So that's still going to be 2x plus 1. So this actually has a 2x plus 1, this part, that came from that, and then the leftovers out front give me my second 2x plus 1. So this was the GCF part, and this is the leftovers. So one way of writing that would be 2x plus 1 squared. Now remember, this is just my scratch work because I still have an x out in front of all of that. So my final factoring is x times 2x plus 1 squared, or you could write x times 2x plus 1 times 2x plus 1. I'm okay with that as well. All right, so the only other thing I wanted to put on this video is that I'm going to do 1 or 2 of the rational expression ones. There'll still be some that we'll do in class together at our next meeting. So when we were in class, we did A part already. Excuse me. So I wanted to do B because it's related to what we were just looking at with the perfect cubes. And to remind you, when you multiply 2 fractions together, so this is just a reminder, remember, if you're multiplying 2 fractions together, you do top times top, bottom times bottom. If you're dividing 2 fractions, you have to do what we call multiplying by the reciprocal. So I'm just kind of giving this example to remind you of what that is. And then notice that just comes out as 2. So this is just a rule of fractions. So when you're doing one of these rational expressions, your first step should be to change this to multiplying by the reciprocal way before you try to factor anything. So I'm going to rewrite this. First fraction stays the same. This becomes a times, and the second fraction flips. Then we factor everything all the way across. So this guy is 2 perfect squares. That's going to factor into a plus 2 and a minus 2. This one up here is 2 perfect cubes. So we need a binomial and a trinomial. A plus 2, because that's the cubed root of each of those. And then I do a times a, which would be a squared, a times 2, which is 2a, 2 times 2, which is 4, and remember SOAP, same as the original sign, opposite of the original sign, always positive. And then we need to do this one as well. So that's also a cubed minus 8, so it's exactly the same factoring except the sign is different. So this one will be a minus 2 and then a squared plus 2a plus 4. So notice the only 2 difference between whether this is a minus or a plus is where the negative falls in the factoring. Now once you've factored everything, I like to write it very simply all as one big fraction. So top times top, I always put my smallest things first. I'm going to put my 2 binomials first. Then I have my trinomials, so I'm just writing them one right after the other like we're multiplying. We are not actually going to FOIL any of this out. That would be overkill because we're hoping that something on the top will cancel with something on the bottom. So notice that's everything from the top. On the bottom, the smallest thing I have is an A, and then I have an A plus 2 and an A minus 2. To be able to cancel something out, there has to be an exact copy and everything has to be multiplying together. So the A plus 2's can go and the A minus 2's can go. My final answer is I don't want to FOIL any of this out. I'm just going to leave it factored. I have an A squared plus 2A plus 4 times an A squared minus 2A plus 4 all over just the letter A. This A cannot cancel with anything on top because it is a monomial and those are trinomials. You cannot partially cancel things that are polynomials with pieces that don't have the same number of terms. So that is finished. And then the only other one, and this will be the last one for the video, that I wanted to do, actually I think, yes, this will be the last one. I wanted to talk about adding and subtracting. So when you add and subtract, you have to have a common denominator. So anytime you're adding or subtracting two fractions, and you notice we'll have another one to do in class, you want to factor all the denominators first to see what the common denominator would be. So I do notice that I have two perfect squares with a minus sign, and the square root of 9 is 3, so this will be t plus 3 and t minus 3. So it looks like my least common denominator is that I need at least a t plus 3 and a t minus 3 because all of them seem to have those things going on. And we need both so that they'll all have the same denominator. The next step is to write each fraction and ask what is it missing. This one is missing a t minus 3. So we're going to multiply the bottom by t minus 3 because that's the only way to make it happen. And if we have something multiplied on the bottom, we must also multiply it on the top. That's to keep the fraction balanced. It's really like multiplying by 1. Then I'll write my symbol plus. I have my 4t over t minus 3. And I ask, what is this one missing? It looks like it's missing the t plus 3. So I'll write that on top and bottom, multiplied. And then I write my minus sign, and I bring down the 18. I go ahead and write this factored out, so t plus 3, t minus 3. And this one is not missing anything because it has both of the pieces that it needs in the bottom. So our next step is to multiply and distribute some stuff out. So this will be t squared minus 3t. When you're multiplying this next piece, this plus goes with this when it multiplies. So we are multiplying everything by positive 4t. So that would be plus 4t squared plus 12t. This has nothing to multiply on top by since this was already okay, but we do need to bring the minus 18 down. All of that is over t plus 3 and t minus 3. Okay, so we need to clean up the top. So we're going to add like terms. So 1 plus 4 would be 5t squared. Negative 3 plus 12 would be positive 9t since they're opposite signs, and we bring down the minus 18. Bring down our t plus 3 and our t minus 3. Notice this is still staying in fraction format because we're not solving anything. This is just an expression. I want to point that out. There was never an equal sign in the original problem, so you're not going to be getting rid of the fractions. Most likely you're just going to have them continuing on. And then here's the problem. You do need to check. We're kind of putting a question mark next to this. Does this factor? Because if it does, it's possible there's a cancellation. So I'm going to do some scratch work over here. So 5t squared, I always put little curls on my t's so they don't like plus signs. It can be really confusing. So we do 5 times negative 18, just since this is a factor by grouping method. And off the top of my head, I don't know what that is. So 5 times 18, I do know that it's negative, so it'll be negative 90. Oop, ink, sorry. So negative 90. I list factors of 90, so 1 and 90, 2 and 45, 3 and 30. I'm just dividing in my head. Does 4 go into it? We have to ask that question. Probably not, but we check. Doesn't go in evenly. Definitely 5 goes into it. 5 and 18, I knew that already. So 5 and 18. We check to see if 6 goes into it evenly. 6 and 15. We need to check 7, which doesn't go. We need to check 8, just working our way up the number line. And of course 9 goes into it, 9 times 10. And we know that that's the whole list because 9 and 10 are only one number away from each other, so there's nothing in between that is an integer. And then we need it to add to positive 9 but multiply to negative 90. So it's going to have different signs, and it looks like it's going to be a negative 6 and a positive 15. That pair will multiply to the negative 90 and they will add to positive 9. So we're going to split this up now, and you can put either one you want first. I'm going to put the 15 first. So plus 15t minus 6t, so notice that's this guy, minus 18. Pull a 5t out of the first pair. That would leave me with t plus 3. This leads with a negative, so pull a negative, and 6 goes into both numbers, so pull out a 6. And that would also leave me with a t plus 3. So it's really good thing that I checked this, because that guy is a common factor with something on the bottom. So this top factors into t plus 3 and 5t minus 6. That was the top. I still have my bottom of t plus 3, t minus 3, and these are identical, so they cancel out. Be very careful here. A lot of students try to reduce this 3 and this 6. That is not legal. You cannot partially cancel parts of binomials. The only way a binomial can cancel out or reduce out is if you can pull a GCF out of here, and then this would also have to be t minus 3. It would have to be identical. So this is my final answer, and it is in reduced format. Okay, so that leaves us with some stuff we'll still have to cover in class next time, but that gets us a little bit more caught up to where we need to be.